Let us class 10 now look at the uses of radioactivity. But before we jump into the uses of radioactivity, let us understand something called radioisotope. Now I had told you there are some elements, or rather there are isotopes of some elements having atomic number lesser than 82 also, which are radioactive. Like for example, cobalt 60, okay, carbon 14, potassium 40, phosphorus 32, they are all radioactive. Okay, these are isotopes of cobalt, carbon, potassium and your phosphorus respectively. These are the radioactive isotopes, remember. And these radioactive isotopes of certain elements having atomic number lesser than 82 of course are what are called your radioisotopes. Okay, now radioactivity is shown by nuclei which are unstable, like I told you. Alright, now which nuclei are radioactive or unstable, so to say? Basically nuclei where the number of neutrons is greater than the number of protons. Okay, so if the number of neutrons exceeds the number of protons inside the nucleus, then what happens is basically the nuclei or the nucleus becomes radioactive. Remember. Alright, so it is these radioisotopes now which find their uses in different fields like scientific field, medical field and so on. Let us therefore study the use of radioactivity. So first let us discuss the use of radioactivity in the medical field. So you must have heard of radiotherapy when we speak of cancer patients. Okay, so in case of a cancer patient, what is after the surgery you have something called radiotherapy and also chemotherapy done. Chemotherapy. Okay, but here we are talking about radiotherapy. In radiotherapy what happens is the cancerous cells of the patient is hit by gamma radiations from the radioactive isotope of cobalt 60. Okay, so this gamma radiations, they hit the cancerous cells and kills the cancerous cells. So that is what is called radiotherapy, remember. And the other uses, gamma radiations from different radioisotopes are also used to sterilize instruments like syringes, basically medical instruments, syringes, bandages. If you want to sterilize other instruments also, of course, maybe in the lab you can use gamma radiations. Okay, so this is basically medical use. And scientific use, talking about scientific uses, alpha particles from different radioisotopes are used to bombard some target nucleus. If you have heard about Rutherford scattering, I don't know whether you've studied about it in your chemistry also or not. In Rutherford scattering experiment, what happens is Rutherford bombards a thin gold foil by alpha particles. So after the Rutherford scattering, or rather Rutherford alpha ray scattering experiment, we got to know about the about the atom, about the structure of the atom rather. Alright, so alpha particles are used to bombard any target nuclei, and it is also used in radiocarbon dating. Now what is radiocarbon dating? In radiocarbon dating you have a very you excavate a very old archaeological site or very old rock. So in order to know the age of those very old rock or archaeological site that has been excavated, that has been discovered, okay, people use radiocarbon dating, in which they study the rate of decay of carbon 14. Rate of decay of carbon 14 meaning by the emission of beta particles, of course. So when carbon 14 emits beta particles, what happens is, we've already seen, it turns into nitrogen plus beta particle, of course. Okay, so they study the rate of decay. So this process of a radioactive substance emitting alpha beta particle, and in turn the parent nucleus turning into a new daughter nucleus is what is called decay. Alright, so in radiocarbon dating, they study the rate of decay of carbon 14. Alright, from this study of rate of decay of carbon 14, they can estimate the age of old archaeological sites or old rocks. So that is what is called radiocarbon dating, remember. So basically these are the uses of radioactivity. You have some industrial uses also, okay, but if you study this much, I think it will be more than enough. Let us now, class 10, discuss the harmful effects of radiations. Too much exposure to alpha particles, beta particles and gamma radiations, it's dangerous for us, okay, especially exposure to gamma radiations. Alright, it will be very, very dangerous because it can simply penetrate our skin and hit our vital organs. Okay, now if we are exposed to these radiations, alpha, beta and gamma radiations, mind you, alpha, beta are not radiations, they are particles. Gamma is a radiation, of course, but before people came to know that alpha, beta were particles, they thought they were some kind of rays, they thought they were some kind of radiations. So till today, very loosely speaking, we use the word radiation for alpha and beta particles also, remember that. Okay, but alpha and beta are actually particles, they are not radiations, remember that. So let me use the word radiation for alpha, beta also, okay. So exposure to these radiations, small amount of exposure can cause recoverable effects like diarrhea, loss of hair, nausea, vomiting, okay, and you can have a sore throat also. Very limited, small amount of exposure can cause these effects, recoverable effects. Now, a bit more long-term exposure to radiations can cause leukemia or blood cancer and simply other kind of cancers too. Okay, so long-term exposure to alpha, beta, gamma radiations can cause cancer. Okay, it's dangerous therefore. Not just that, if I'm exposed to alpha, beta, gamma radiations, for a very long time, then what happens is it can cause genetic changes in the living cells, of course, of the upcoming generation, of my upcoming generation, so to say, if I am exposed to alpha, beta, gamma radiations for a very long term, okay, this is what happened in case of when Nagasaki and Hiroshima in Japan were bombarded with atomic bombs. So those atom bombs are basically fission bombs wherein we use uranium, basically this isotope 235 of uranium. Now uranium is radioactive, so after the bomb exploded, okay, of course lot of people died, but whoever managed to survive, those people who managed to survive, they were exposed to these radiations, alpha, beta, gamma, and what happens is long-term exposure, they were exposed to alpha, beta, gamma radiations for a very long term, and that caused genetic changes in their upcoming generations, in their later generations, so to say. So the later generations of those people who were exposed to alpha, beta, gamma radiations, they were born with some kind of a deformation, alright, some kind of changes in their genetic code, so to say. Okay, so these are therefore the harmful effects, very, very harmful effects of alpha, beta, gamma radiations. Very harmful, very, very harmful. This is recoverable for very limited exposure to alpha, beta, gamma radiations. Let us now discuss sources of harmful radiations. Number one source of harmful radiations is radioactive fallout from nuclear power plants. Now you have nuclear power plants from where a lot of heat energy and thereby electrical energy is generated. We have nuclear power plants in India too. Okay, so what happens is, due to some reason, if the nuclear power plant gets damaged, alright, where you have the reactor, wherein the nuclear reaction of fission goes on in the power plant, then if somehow, due to some reason, that particular portion gets damaged, what happens is, from the nuclear power plant, therefore, a lot of alpha, beta, gamma radiations can be emitted. And thereby, if we get exposed to those, alpha, beta, gamma radiations, it can cause, of course, harmful effects on us. Like, I don't know whether you've heard of this or not, in 2011 in Japan, when there was this earthquake, major earthquake, because of which a tsunami also happened. Alright, there is a nuclear power plant in Japan by the name Fukushima power plant. Fukushima. Now what happened is, because of the earthquake, some parts of the Fukushima power plant got damaged, and because of which what happens is, radioactive radiations, that is alpha, beta, gamma radiations, started coming out or started getting emitted of the nuclear power plants. Okay, which of course was dangerous. Now, nuclear waste. Now, from nuclear power plants only we get nuclear wastes. In nuclear power plants, we use uranium, remember, uranium-238 and uranium-235, two isotopes of uranium. Basically, we use uranium-235. Okay, this isotope of uranium is used basically to make atomic bombs and also in nuclear power plants. Now, after you use uranium in the fission reaction, there is a fission, something called fission reaction. Fission reaction is a nuclear reaction, remember. So, there is nuclear fission that goes on, that is, uranium is used for that. And after the fission reaction is complete, the uranium, whatever uranium remains, that is to be thrown, that is the waste now. Although it is waste, it still will be radioactive, remember. So, you cannot go and dispose uranium wherever you feel like. Out in the open, you cannot do that because it is radioactive. Alright, so proper disposal of nuclear waste is required. Either you dig, in a very isolated area, many meters deep, you dig the ground and you dispose the, nuclear waste over there. That too, the nuclear waste is to be put in a very, in a trunk, so to say, made up of lead, very thick lead, okay? Because gamma radiations cannot pass through, cannot penetrate thick lead plates, so to say. Okay, so uranium is to be placed in a thick trunk, so to say, made of lead, alright, and then it can be disposed deep down inside the ground, alright, or it could be placed deep down inside ocean. Okay, so proper disposal of nuclear waste is required, otherwise it can emit, if you dispose it anywhere in the open, it can emit harmful radiations, alpha, beta, gamma, and thereby it will be very dangerous for us. Then cosmic radiations also. Okay, this is to a lesser extent than these two. Now, what are cosmic radiations? Cosmic radiations are radiations that we get from outer space, including the radiations that we get from the sun. It is not just white light that we get from the sun. There are various dangerous, gamma radiations, ultraviolet radiations, X-rays also that is being emitted by the sun. Now, not just the sun, from outer space also, from different locations in the space also, there are different radiations that are entering the earth. Now, most of the radiations, they do not reach the earth, okay, because it is blocked by the atmosphere, alright. Not just that, the magnetic field of the earth deviates those different radiations also. But some amount of radiation still reaches the earth, the ground, that is coming from the outer space, of course, okay, and those are what are called cosmic radiations. Now, cosmic radiations can also be therefore dangerous to human beings if they can easily reach the earth. Finally, let's talk about something called background radiation. You might get one mark question, what is background radiation? So what happens is, background radiations are of course radioactive radiations, alpha, beta, gamma radiations, to which we are all of us all the time exposed. Okay, we are all the time exposed to background radiations. But the thing is, background radiation does not exceed the maximum permissible limit for human safety. So it's not very dangerous, so to say. Alright, and of course, we cannot keep ourselves away from background radiation. We cannot, so to say, escape from background radiation. We are all the time, all of us, exposed to background radiations. Now, the sources of background radiations are internal sources and external sources. Now, in some vital organs of our body, inside our body, of course, you have radioactive substances like potassium 40 and carbon 14 present inside the human body itself. So all the while, these things will be emitting, very small amount of radioactive emissions. This is therefore the internal source of background radiation. External sources, like we have already discussed, cosmic radiations and also solar radiations, okay, that we get from outer space, okay, that we get from outside the earth. They are also sources of background radiation. Okay, so like I've already mentioned, we cannot escape from background radiation. All the time we are being exposed to background radiations, but it is not harmful. So this is about background radiation, and this ends your chapter, your topic on radioactivity, class 10. Thank you.